Hey guys, what's up? This is going to be another exciting episode, and this is from Biomolecules. And what this is, this is about. This is going to be the last topic from glucose section. In case you do, pay attention and find out. And though this is not something you might find in NCERT, but this is called mutarotation. So this is again something very important from the competitive point of view. And this is really something that you're going to like it, and at the same time you also going to get it quite an easy way, but when you pay attention. That's very important thing you have to focus on, right? So let's start that and see what this mutarotation is about. Let me introduce to you about the definition here. You know what, I have already told you that they are basically plain polarized light. So what is a plain polarized light? It is the light which scatter in only one direction. What happen? An ordinary light scatter or travel in all direction, right? But a plain polarized light travel in only one direction. So when you pass a plain polarized light through a glucose solution, either it is beta or it may be even alpha, so whatever. So what will happen, that PPL will undergo rotation. So this rotation, is the main topic here, and I will explain you so many things about here. So let's concentrate and see how this mutarotation, exactly is going to you. So before that, before coming to the conclusive line, I tell you what, suppose, this is a plain polarized light here I'm trying to draw. So this is a plain polarized light. Now what you have a container here, and this contain alpha glucose solution. This contain alpha glucose solution, right? And then I'm taking another instance of the same. We have this plain polarized light, we have this plain polarized light here, and you have another container. Suppose it has only beta, glucose. It has only beta glucose. So this is going to be a beta glucose solution, right? Now, what happened here? When this plain polarized light passes through alpha glucose solution, both of the glucose molecule are here, dextrorotated. They are both dextrorotated. But the angle of rotation is different for both of these. The angle of rotation for alpha glucose solution is different, and for beta it is again different. Now the question is, how much this will cause the rotation and how much this will cause the rotation. When this light will pass through the solution, pay attention, this is really important. Rotate PPL about 112 degree, and similarly this beta glucose solution will rotate the PPL. What PPL is? Plain polarized light, by around 18 degree. Now the question is, how I even know that? The simple answer is that I don't know that. It's been experimentally determined. So that's why I'm repeating, right? So these two values are coming from experimental evidence, right? That the solution of alpha glucose will rotate the PPL about 112 degree. However, the beta glucose solution rotate the PPL about 18 degree, right? This is not even the exact value. There may be some point fraction as well. But you need to pay attention that this is the total rotation it is, getting. Now, pay attention here because I am taking it to a different level. In case you know that very previous lecture, or maybe one or two lecture back, I described you that alpha and beta form of glucose, they are interconvertible because they go through reversible changes. What that means? That alpha changes to beta and beta changes to alpha, right? So what you did, suppose you placed alpha glucose, and then what will happen? This will turn into beta glucose. This will turn into beta glucose. So what is happening, like this one is giving you 112 degree rotation, but this one is giving 18 degree rotation. Now what that means, it is not necessary, you have to pay attention. It is not necessary that the rotation is going to be fixed here. Why? Because it depends on the concentration of the alpha changing into beta and beta changing into alpha. Now pay attention here, in that suppose, the alpha and beta, these two are present here in the solution and they are interconverting. Let's imagine that this alpha is about, 80%. Suppose this is about 80% here and this is about 20% here. Right? What that means, 80%, alpha is still there. However, due to the reaction condition, 20% of alpha has converted into beta. Now the question is, how can we calculate the angle of rotation? Because this will not remain 112, because this will decrease and this will increase. You need to understand. When alpha, D-glucose changes to beta D-glucose, the angle of rotation, which is 112, will start decreasing, and 18 degree, which is for the beta, it will start increasing. Now the question is how much, it will be increasing and how much it will be decreasing. So for that, I'm giving you a calculation here, which is really very important, though it's not important for your board exam, but definitely going to be useful for your competitive exams here, right? So how that is calculated, just pay attention. So I'm just giving you, angle, let me write here, angle of rotation, angle of rotation. You have a formula here, and that is, 80% into 12, 80% into 112 plus, that is 20% into 18 divided by 100. Okay, so the angle of rotation can be calculated by this particular formula, depending on the percentage of the, glucose form, and multiplied by their own, rotation, and similarly the other one also divided by 100. So this will be the, angle of rotation. Suppose this is coming out to be x degree. So this is, something you can find out depending on how much, beta and how much alpha is there inside the, solution. Right? I hope I made you go, but in case you do not, just pay attention. You might, you may have to repeat the whole lecture, because if this is for the first time, you might find it, a slightly, difficult. But I would say it's not difficult at all. Why? Because this is something you've been talking about, you have idea what PPL is, right? Let me repeat back every concept I just made you. PPL, it's a light that do not travel in every direction. It travel in one direction. So when you pass a PPL through a solution like alpha glucose, it will rotate about 112 degree, and if you pass the same light through the, beta, it will, it will rotate by around 18 degree, right? But as you also know that in a mixture of, in a solution of alpha, the alpha constantly changes into beta. So why? Because this is a reversible reaction. And suppose in a solution of alpha and beta, the alpha is about 80% and beta is about 20%. So how can we get to know what will be the overall rotation? So this is, what you can do in order to find out the angle of rotation. Pay attention. This is really, really important. This is really, really something you cannot ignore. Okay. So what we need to do right now, just pay attention here. Now we are up to the final, mutarotation part here. Like I said, in the mixture, in the solution, the alpha D glucose, just pay attention. This is, very important. Alpha D glucose is constantly changing into beta D glucose. This is what is happening. Beta D glucose, right? Beta D glucose. Okay. So the thing is that, the angle of rotation here is constantly changing. What that means? The rotation will not remain 112, the rotation will not remain 18 degree, and it will also not remain, any value, maybe x degree. This is constantly changing. Now the question is, what will happen ultimately? Once alpha and beta, they have come under equilibrium. Pay attention. Once alpha and beta, they both are under equilibrium, at that moment of time, the rotation will be stopped. The rotation will become fixed. I'm going to tell you what value that will be, but just pay attention again. In a solution, the alpha is constantly changing into beta and beta is changing into alpha. So how long this conversion will take place? As long as there is no equilibrium. So once the equilibrium is established, this conversion will stop. And if it stops, at that moment of time, the rotation is called mutarotation. At that moment of time, it is called mutarotation. So let me define here. The rotation the angle of rotation, at the time when alpha and beta form of glucose are under equilibrium. I'm not going to write, you just listen again. It is the angle of rotation, when alpha and beta form of glucose, they are under equilibrium. I'm repeating for the third time. It is the angle of rotation when alpha and beta form of glucose are interconverting into each other, and they are, they have attained equilibrium. At that moment of time, the rotation is called mutarotation, right? So in case you need, let me write, because you might need here, it is defined as angle of rotation, at equilibrium when alpha D glucose stop converting further into beta D glucose. So now the question is, what will be the rotation? And I tell you what here, finally, this rotation value is about 52 degree. 52 degree is the rotation, angle of rotation, which may be around 52.45 something. So 52 degree is the angle of rotation when alpha and beta form of these, glucose are under equilibrium. So this is what mutarotation is. I hope I made you go as simple I could make. In case you find it difficult, go back, repeat it, practice it, and let me know how this was. I would say thanks for watching, comment back and let me know, right? And that's it.